Welcome to the Oscillations and Waves component of the core physics unit. In this unit we'll be looking at how waves and oscillations can be used to describe matter, particles and wave functions. As an overview to the course, we're of course going to be looking at oscillations. We're looking at the oscillations of masses on springs, considering things like the equations of motion, how these systems can set up simple harmonic motion, and we'll be looking at how the oscillations behave under damped and forced motion. We'll then move on to simple wave motion. So how harmonic waves behave, how they reflect. We'll consider about how waves superpose with each other and form standing waves. We'll then look at Doppler shifts, what happens to what is observed about the frequency of a wave as there's relative motion between the source and the observer. We'll then move on to Fourier analysis. So Fourier analysis is breaking down a wave into its constituent parts to see how the different components superpose to create a complex waveform that we observe. We'll then be looking at wave packets and how they disperse, and then we'll be considering the interference and diffraction of waves as well. This leads us on to examining the properties of light and how light reflects, how light behaves through basic geometric optics. And finally, we will introduce how oscillations and waves behaviour can be applied in quantum mechanics under the wave-particle duality. We'll be delivering this course through a means of media. We'll be using the online notes. These will be the primary content and contain everything that you need for the course. It will have full mathematical derivations where appropriate, but we will not be covering these as part of the videos. Rather, in the videos, we'll be focusing on covering the physics. We won't cover every detail of the notes, but we will introduce the mathematical derivations where it enhances understanding of the physics content. You will need to flesh out the content of these videos with reference to the online notes and the course textbook as well. And finally, there will also be private study. You will be expected to do a certain amount of private study rationalising between the various sources of material. It's useful to consider the story of the course, so what we'll be talking about as we go through. When we think of oscillations, we'll initially be looking at ideal oscillations, ignoring things like damping and friction and so on. Once we get over that, once we understand the equations there, we'll start adding realistic effects. So what happens with damping and driving. We'll then be using mathematical tools to facilitate the analysis and the modelling of these. In particular, we'll be using the complex numbers to simplify combinations of effects. Some components of waves, by examining with complex numbers, it makes the mathematics easier. We'll then move on to looking at waves and wave behaviour. And specifically, we'll be looking at simple waves and the wave equation of simple waves and how they propagate. And then we'll look at how waves superpose, and how they interfere with each other, and how they diffract. We'll then talk about the Fourier analysis and how we break down a complex waveform into its constituent harmonic wave components. We'll then be looking at optics, and this will be a very simple approach to optics, but we'll be examining phenomena such as total internal reflection, how mirrors and lenses behave, and ultimately how wave behaviour affects our ability to resolve objects at given limits. Finally in the course, we will introduce a little bit of quantum mechanics. This will be a very, very brief introduction to quantum mechanics, but we'll cover the parallels between classical waves and quantum systems. When we think of wave functions and the wave-particle duality, understanding how waves behave can really help us understand the quantum nature of matter. As part of the course, there are a certain number of prerequisites which you should revise. The first of all is vectors and vector notation. It's very useful to be able to think of waves in a vector form. And you should also be happy with your equations of motion as well, as we set up the differential equations required for oscillations. You should also be familiar with the application of calculus to the mechanics that we're talking about. You will also find it useful to revise reference frames because by simplifying things into a moving reference frame, we can simplify the mathematics of wave motion. So being able to move between different reference frames is a very useful thing to be able to do. I hope you enjoy the course. Make sure that as we go through it, you take the opportunity to ask questions of me, of your colleagues. You also take the opportunity to answer questions of your colleagues, and make sure that you take the opportunity and the time to relate everything that you've done so far in physics to this new material. Everything is interlinked, and the stuff that we're talking about here will absolutely help support your learning elsewhere on the course. Thank you very much, and enjoy the course.